Here we have something new for the channel. A humidifier, not a dehumidifier, a humidifier. So this is actually supposed to put water into the air. So with a dehumidifier, it takes water out of the air and collects in a tank. With this one, you add water into it and it's supposed to add water to the air. Never looked at one of these before, so I have zero idea how it works. It looks very complicated down here, but maybe when we take it apart, it might become more obvious. If I turn it on here, it shows no sign of life. So I can hear it click on, but it's not making any sound, no lights come on, and no motors are running or anything like that. So let's bring it over to the mat, take it apart and see if we can work out how this thing works and see if we can work out why it's not working. Hopefully it will be interesting. Right, it's missing the little fuse thing here, so I'm just going to put another one on there. And I've taken the water out of here. It says here, please do not get water into the air vents, which must be just these bits here. This is supposed to be some filter. Oh, okay, so the balls is just part of the filter, so we shouldn't have to worry about that. That's plastic there. Just going to empty that water out. So that has to be a float. So when there's water in here, it does that, which lets water come down from the top into here. And I suppose when this empties of water, it closes it to shut the top off. But I don't know the direction of water. Is that the feed of water and then it comes up through the middle? I'm not too sure, because we have this weird funnel thing going on and this thing here. So maybe this is what kind of does the spraying part of it. Right, we've got screws in here, let's undo them. Obviously, I'm unplugged. And I bet we have to pull off this knob at the front. That wants to come out. I'll pull this out. Let's turn it off. Is this going to come out? I don't know. Yes, it is. Okay, so now I'm going to have to undo that, aren't I? Right, I can see a little bit of rust there, so this might be water damaged, because I can see just around here there's a little bit of staining. Yeah, can you see all the rust here? Oh no, I think this is water damaged. So water has got into the bottom somewhere. Do you know what it probably is? I reckon the on and off switch is not working. I think that's what's happened. So this is the fan. LED here. So an LED is supposed to light up. We have something here which must detect if there's water, maybe. Got a bit of rust on here. Yeah, even the opto coupler is rusty. Let's undo this and see what it looks like on the other side of the board. So I wonder, would it be like an atomizer when it's spraying the water? Oh, here we go. We have a, look at that, we got a three-legged thing here on a heatsink. I wonder, is that a voltage regulator? I need to undo that in order to see underneath. I think the problem is going to be on the front board. I just want to see what sort of damage is under here. Quite a lot. I think that might have been eaten away there, I'm not sure. Resistors don't look too clever. I think when we put IPA on it, it probably will look okay. This could be a problem here, this resistor, possibly. Let's not worry about that just yet. Let's have a look here, because I think this is the problem. I think when we're turning this, it's not turning on. So let's go to continuity and see if we can hear what's happening. So let's turn it on here a minute. Let's see, where are we? So I don't think anything's changed there. One, two, three, 1, 2, 3. That one's not even soldered, so that's a no connect. So would it be just between here and here, or here and here, that we should have something? So we haven't got anything there. Let's turn it off. Hold on. That's off. Nothing. Oh. No, we have got it going on there. We have got it going on. Now, have we got a resistance between here and here? Right, so that's nearly a direct short. Let's twist it. Oh yeah, it has changed. I think that's working. Unless, has it just started working because I've turned it upside down and twisted it a bit? Yeah, not 100% sure about that, because when it clicks it seems to have a, it still seems to be giving me a reading. Now, so, got to be careful here because we have big capacitors, 400 volt. Let me see if we've got anything in these. I should have done that earlier on because I had it plugged in. Wow, we still got 90 volts in there, and there was me messing with it. We haven't got anything on that one. Yes, we have. Yeah, 88 volts. Got to, you see, you got to be so careful. There was, I had my paws all over that, and there could have been 200 volts on it earlier. So clearly the bridge rectifier and the so this must be acting as a, where is the bridge rectifier? Oh, this is the bridge rectifier here. So that's all working because we've got voltage in the caps. This might well be working. I'm tempted to put it back together. There's no point in draining that because I'm going to be putting this back together. I want to see if it comes alive now, because I'm still thinking the on and off switch has just come alive. Right, so let's just turn it on, and I won't put my hands anywhere near anything. See if this fan starts spinning. Oh, I wonder, does it need water? Does it need to recognise water in here? Well, we'll see. Maybe it will come up with a light or something. So we're on, so as soon as we plug it in, it should do something. So I'm going to plug it in now. And there's nothing happening. Okay. Unplugging it. Let's see if we have high DC voltage on that cap. 15 volts. That's not right. We had higher voltage before. Oh, here we go. 280 volts. So definitely that part of it there is working. I wonder where the output is then. Shall I go across this capacitor here? Because this looks like it's on the output. Nothing. I think the problem is on this board then. I think we'll give it a clean up once the power's gone, and we'll measure across the resistor, clean up the capacitor and stuff. Maybe this is giving some weird reading. But if we've got voltage here, which we have, then you think we should still have voltage on the output capacitor. 200 volts. I'm pretty sure there should be something here then. Okay. Right, I've got a load of resistors in here. I'm going to try to drain the cap down, the caps, so I can work on it safely. Right, you can see now there's no voltage there. 6 volts. That's fine. Right, I'm going to take a picture and I'm going to unplug all the leads. Ta-da! Right, let's get rid of this for a moment. That definitely needs a little bit of work. I don't think that's why it's not working. I'm just going to see if I can get my head around this a little bit. Right, so power comes in over this side. Goes up here through the bridge rectifier into the first cap. And goes through the coil into this area, and we know we're getting voltage here, so the coil and stuff must be working. And then it looks like we have a little chip here, and that must be to do with the switching, I'm thinking. We have the optocoupler for the feedback, and these are going to be some sort of output capacitors. Don't know what that is. BU406, I'm not quite sure what that is, if I'm honest with you. Where's the diode after this? Would it be this one here? To rectify it down? Yay! We got one of those 431 things that we had in the desktop lamp light thing. So that's to do with the feedback, which is near that there. I mean, that's very rusty. Okay, I think we'll zoom in and we'll see what's happening with these little resistors here. So resistor 19, 47, maybe 471. Let's see, are we getting any reading? We are, but it's well, it's 0.2 meg. See if there's a short here. Is there, have we got anything between here and here, or is the track gone? No, that's working. Have we got anything between here and here? Yes, we have. I think let's get some IPA and clean this area up, and then we'll have a better idea of what's going on. So I unleashed the wonder stuff on it. That is isopropyl alcohol, 99.9%, and I just give everything a really, really good clean. Isopropyl makes everything look amazing, but corrosion has still happened on this board. So I test every single resistor just in circuit, and I'm getting a reading, but it doesn't mean it's the correct reading, but they are in circuit. And I'm going across the diodes, they seem to be testing okay, and I'm going across a few of the capacitors just to check for shorts, and that seems to be okay. So we're going to cut to the part of the video now when I found about 3 resistors that don't really look right, but it's very hard to tell because they are in circuit. Well, I've been having a good look around the board, and I can't really find anything wrong when I'm testing stuff, but we have got 3 resistors that I'm unsure about. This one, and this one. And it looks like this one does go right the way around to feed the chip. So this might be the voltage for the chip. Yeah, the markings are completely gone from them, and they just look a bit bad. Also, this one here looks like this end doesn't really exist, but I am getting readings across them. So if I go here, but I want to read them out of circuit, because maybe I'm reading the circuit itself. So if I go across this one here, this is 474, which I think should be 470,000 ohms. And that's 290, but it's in circuit. So I could be measuring the... no, that's higher though. Yeah, that's probably actually okay. This one, I don't know what it should be, but when I go across it, it's just like growing. So I don't know, that might be the circuit. And this one here does seem more stable. So that might be correct. I'm unsure about this one. And this is feeding the chip. Because look, if I go into continuity, from here, it goes up to here, and then round to here, and then to here. And that one there is the positive of the little capacitor here. And I think that's the startup capacitor for this chip here until it starts working from the windings. But anyway, I think I'm going to slide these 3 just off and measure them out of circuit. Right, I'm using 450 degrees Celsius, 150 out of a possible 200 airflow. Now I don't think these are glued, I don't think this is wave soldered, so hopefully it will come off easy enough. That did a nice flip. Oh well, that's out of circuit now. And that board popcorn there, and I got a nice tombstone on that. I did a double whammy. Tombstone and a bit of popcorn in. Well done, Vince. Right, so I think this resistor is going to be okay. It is warm. Yeah, maybe. 600,000 ohms. Possible. I really don't know. Okay, that's inconclusive to me. Let's try this one here. This is the one I think might be dodgy. No, maybe not then. It is giving me the same sort of similar reading, I think. It's in the mega ohms again. That might be normal. Right, let's try this tombstone in one, where I popcorned the board, but I think I'm okay. Oh, hello. Oh, no. 295. 4 7 and 4 zeros. 470. Annoyingly, that was really inconclusive. Right, I'm going to add some fresh leaded solder to that and pop those all back on. I think the reason it popcorned is I didn't heat up the board enough. I just went straight in for the kill. Right, I think I'm going to plug it in. I want to see if any voltage is getting to this little startup cap here. This one here. So I'm going to be very careful because obviously I could kill myself. I'm going to keep my hands well away from here and try to use the probes just gently and see if we get anything. And then afterwards I've got to make sure that we haven't got any power in the caps. Well, I am going to plug it in now. Right, so we're plugged in. First of all, let's see if we have anything on the output. So output cap is up here. Just in case it started working. No. Right, let's go on this cap here. So negative is this side. Whoa, 140 volts. Okay, hold on. 140 volts, that's where it's coming from. 298 volts. 334. Why have we got such high voltage? Is it because it's not under any load? Why is that cap not blown up then? Worried now. Let's unplug. 140 volts on the cap. What's that about? That means we've got 140 volts feeding that chip. Have I got a weird ground? No. That's showing 140 volts going into that chip. Carefully, I just want to see what the capacitor is. 50 volts. 2.2 microfarad, 50 volts. It's very hard because I can't get the readings off the chip, so I don't know what it's supposed to be, but there's no way a 50 volt cap should be having 130 volts. But I think it's because it's not under any load. Like when we did the LED on the Milwaukee thing, I had like 20 volts when the LED wasn't there. But then when the LED there, it's going to go down to a sensible voltage. So I think it's because it's not actually working that's what that voltage is. But that's really confusing. I'm unplugged, but it's keeping its power. Wonder has that chip failed?
So I think it's the chip, but I'm not sure, so I'll take out the optocoupler. What? It's because I haven't got a spare chip to put in. And the optocoupler is rusty, and it's an easy thing to test once it's out of circuit. So although I do think it is probably the chip, and it's confusing to me why there's such high voltage feeding the chip, but again, I think it's because it's not working. I'm sure if there was a proper path down to ground, then you might well find that through that chip that there might only be 5 volts or 10 volts or something like that. So I can't believe it's a true 140 volts. Otherwise, that cap would go up in smoke because it's only a 50 volt cap. So I'm taking out the optocoupler purely to test because it's rusty and it's an easy thing to test. But I do think we're probably going to have to look in to see what we can replace this 6-legged chip with.
So this little optocoupler is an EL817, and I googled it, and this is the pin out here. So what I'm going to do is on the anode I'm just going to put a 1k resistor because it's like an LED, and then I'm going to put my multimeter on 3 and 4, the emitter and collector, and I will see the resistance change as I up the voltage. I'll start at something like 2 volts and then go up to 3 volts, and we should see the resistance change. I know number 1 is the anode because it's got a tiny little circle just here. So I need to put this onto this one here. You can see rust underneath it. Just going to flood it with solder. There we go, is that strong enough? Yeah. So we've got the resistor on the anode here. Let's get the bench power supply, put it right down to 2 volts. And that little resistor should protect the inside of this. Carefully putting that to there. And now let's see if I get any reading on the collector and emitter this side. Right, so we are getting 3000 ohms. Let's change it now. Let's go up a tiny little bit. So I'm now at 2.24, so the LED is going to be getting brighter. There you go, 2.4. So now this is going to go, I'm at 2.5 now, so it should be less. Maybe it's going to be 1 point something. There you go, 1.9. And we'll go all the way to 3. 3.08. So now this might be, I don't know, 500 ohms or something. There you go, 600 ohms. Optocoupler's working. I'm going to solder that back in. Well, when I say it's working, it's giving readings. I mean, it might not be within spec, but it's doing something. I don't think it's that. I think it's going to be this little chip here, and I haven't got any readings on it, so I don't know what it is. The only reason I did this here is because I've seen rust underneath it. And if you have a look here, there's a little dot here, so you know where to put pin 1. Right, I'm just going to reflow some of the rusty joints.
While I'm doing that, I'll give a shout out to the wonderful my mate Vince Massive. The members this month are Keemon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJVG, Pigsy, Anthony Dean, Russ Melanson, Rickard Bergland, Shamsa Al Swadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, and AJ Computer Services UK. Massive thanks to each and every one of you.
Well, I'm going to give it one more go. And then I think we have to start looking into that chip. See if I can get the data sheet up for it, or I know other little 6-pin ICs like that. Let's see if we've got anything on the output at all now. No, absolutely nothing. Do we still have that stupid voltage here? Yeah, 141. Okay, I'm unplugging it and draining it down. All right, leave it with me for a bit. I'm going to see if I can find out what that little chip is just there. Whoa! Scared the life out of me. These leads are a little bit big. I shorted across the cap there accidentally. There we go. Nicely drained, probably from the spark. Oh my word, I can actually see it. I IPA'd it and cleaned it with my nail, and the sort of scum came off it, and I can fully see a mark in there. 33P2. That's a H. So I'm going to Google that. Well, those hopes were quickly dashed. It's definitely 33P2H. It's not bringing up anything. Switch mode power supply. Nothing's coming up. Images. Isn't that weird? You would think there'd be some evidence of it somewhere. I'm going to say water got trapped here, and this blew. I did some Xbox fridges ages ago, and they also had tiny ICs like that. I don't know if they were 6-pin. I'm going to see if I've got them, just in case they're a kind of generic 6-pin switching IC. Well, I had a look back at my Xbox fridges video, and most of them were faulty. I did a job lot of them from this little IC here, but luckily I had another one that had a faulty power supply, but it was like output capacitor or something. So I managed to use the switch mode power supply switching IC here, this pulse width modulation one, and put it in the other ones, and then they started working. So I knew this chip was at fault. But I said in that video that I couldn't find them, and it was labelled up as 33134. I said it didn't exist. But I traced all of the pins, and I put it up on camera. So that's useful. So I'm going to use that now to see if this is the same as this one here. So let's zoom in, let's go to continuity, and then we'll know that it's just kind of one of these generic switching IC 6-pin ones. I might even be able to buy one, possibly. So first of all, we need to find out which one is ground. So is this going to be ground here? So we're going to go to the negative off the cap, and here. Yes, it looks like it is. Now, this one here going to the opto coupler. Well, let's see. I might have to zoom in. Yes. This one here is not connected. Does that go to here? Yes, but look, there's no resistor. So it isn't actually connected. It says R28, but there's nothing there. So far, so good. This is going to the positive of the capacitor, which we know is this one here. Yes, it is. And this one here is going to the source of the N-channel MOSFET. Source is this top one. So let's see if this one is going to here, to here. So where does it go? It goes to, from here to here, from here to, where do you go to? 1 second, let me have a look. Yes, you are. Because, look, you go from here, through to here, and then it goes through to here, through the resistor, yeah, which my meter's not going to beep, to here, and this side here goes to there, which is that top one there, which is the source. You can see S on here. And this one goes to the gate of the N-channel MOSFET. And the gate is this one here, which is the top one here. So the gate here, so that one goes to here, which goes to here. So from there, it travels through to here. And here goes to here. So 100%, I haven't got those Xbox fridges anymore. But if I did, I reckon if I put that in, it would start working. I might see if I can just buy a generic 6-pin switch mode power supply. See if it comes to life. Because I've got a feeling that this here is faulty. Because they were all faulty on my Xbox ones. Maybe they're not that strong. They're very small and they do a lot of work. So I'm going to say that this here is faulty. But I don't know that because I'm still worried about why we have such high voltage here. But I think we have high voltage because I think this needs to kind of bring it down. Once there's load on it, maybe it will go down to 20 volts then. Right, I've decided to go for these ones here from AliExpress. 10 of them for £4.25 plus £2.93 postage. So you're looking at around £7.20-ish. And yeah, so 72p a chip, which would be nice if it works. These are the numbers. Why have I gone for these ones? Very simply, I looked at the comments on the Xbox Fridges video, and Anonymous Repair said that he thinks these may work, because I said in that video if anybody knows what this 6-pin IC is. Now, I've always listened to Anonymous Repair because he always gets everything right. I know it's impossible for somebody to be right 100% of the time, but as far as I can see, that guy's never wrong. So yeah, he steered me in the right direction many times, so I'm going to trust him on this one here. I've ordered up 10 of these. When they arrive, we'll pop one in. We'll see if this humidifier will come alive.
A little while later.
Alright, about a week or so has gone past and my chips have arrived from AliExpress. Don't know if they're the correct ones, but this is interesting. If you have, listen here, we know that we have the optocoupler here, and this is to do with the feedback. And this little chip, I presume, is controlling everything. And if we go onto the middle pin, here on the right hand side, it goes through the 0 ohm resistor and it goes to the top of the optocoupler. Yeah, to that one there. So clearly that pin is something to do with feedback. But if we go on to diode test, and if we put the, oh sorry, let me just show you something. We're going to go from the negative of the bridge rectifier, and you can see that the negative from the bridge rectifier is coming up on that bottom pin there. Yeah, you can see that's near enough a direct short. And if I go to diode test, red lead to ground, which I could do here, or here, and go on to the middle pin, it's not giving me any reading. And we know that the 0 ohm resistor is working because you heard it beep a minute ago. And even if I go onto that side or this side here, there's nothing happening. Yeah? But if I go onto this chip down here and I've got it in the same orientation with the little dot on the bottom right hand side, so red lead to what I presume is ground. Very hard to do this, but there, red lead on ground there. Now if I go onto the middle pin here, can you see we are getting a reading? 0.7. But we're not getting anything on here. Now, maybe because it's in circuit, it's knocking it out, but I very much doubt it. I think when we take this chip out, we're going to find that that middle pin's not doing anything. So if it's not reading the feedback because the internal part of that chip has blown where the feedback is, then it's not going to work, is it? Because it's not measuring the feedback. So I think that there is the problem. So let's get some heat on that and take it off, and we're going to pop this one on. And we can actually see that there's a dot just here on the board, so that denotes where the dot on the chip is, just here. Just adding a little bit of flux. Let's get some heat on it and take it off. 450 degrees Celsius, 150 out of a possible 200 airflow. When I mention feedback, via the optocoupler, because there has to be isolation between the high voltage side of the circuit and the low voltage side, otherwise you could risk electrocuting the person who's using this device. So with the optocoupler, there's no way of the high voltage and the low voltage mixing together and creating a short. So the optocoupler is there to measure what's happening on the low voltage side so the high voltage side can adjust. Meaning that if the low voltage side is struggling, then the high voltage side, I presume, can switch faster to put more power through to the low voltage side, so then that device can work nicely. If the device isn't really calling for much and it's working on real low power, again, the optocoupler, I presume that light might not be quite as bright, and then the high voltage side realizes that the low voltage side doesn't need much and it can reduce the power down a bit. So I think it's constantly fluctuating, and that's what makes them so efficient. They're not just constantly putting out the same amount of power, it fluctuates up and down. So if it can't detect the feedback, I presume that the board goes into shutdown because it can't see what the low voltage side is doing. And because on this chip here, those pins were not doing anything, then it can't measure the feedback. And I'm just going to quickly make sure there's no reading on here. Yes, there's no reading there. And now let me just get the chip itself. And I think, yeah, the what's it called is there. So red lead to here. And black lead to here. 1 second, now swap over. Definitely not getting any reading there on my meter. Right, okay. So I must stress, I don't know if this is the right chip or not. So what we're going to do is we're just going to put solder on one of the legs. We're going to put this on with the soldering iron. That will hopefully keep it in place. So let's make it easy for ourselves. Let's do this one here. Here we go. And now try to place this on. Right, I think that's all right. I'm going to try to move it up just a tiny bit. There, that's nice. Right, let's add a little bit of flux and solder up the rest of it. I can't seem to get any on that, hold on. Let's do this side. There we go, nice and blobby. Give that a clean up. Right, so that's not shorting against there, it's just the circuit board looks a bit white under there. There's no shorts there. And they're covered in solder. So let's zoom out, make sure now that we have a diode reading. And then I think we have to plug it in and see what it's doing. Right. So now if I was to go to the negative here, and for example here now, are you going to give us something? Whoops, wrong one. Here. There you go. So you can see now through that there, all the way to the optocoupler, I have something. And that's coming from the chip itself, internally on the chip. So that's the ground there. So I've got something there now. And I didn't have something before. But the chips are different, aren't they? Right, do I need to put this back on? Will it burn up straight away? Or should I just plug it in for a few seconds to see if we have voltage on here? Oh, I'm nervous. I would normally be doing this across the room, but I'm thinking it's just going to blow that chip. I don't think there's going to be anything too catastrophic. Famous last words. Right, so are we okay to go? I think we are. Let's give it a go. I'm just going to plug in and unplug very, very quickly. You ready? I'm going to plug it in now. Plugged in, plugged in, plugged in, and unplug. I'm unplugged. Carefully turn this over. Let's see if we have anything on the big capacitor. Please have something here. Please, 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 please. Oh, No. Oh! We do? There was something there. Right, I think I'm going to be brave and measure it when it's plugged in. Have I got enough time to do this? I don't want this to overheat, you see. But look, voltage went to nothing. Right, let's be quicker. Let's plug it in. Right, I'm in. Let's just quickly do it now. Is there anything there? Yes, 14 volts. Brilliant. Did you see that? Hopefully you've seen that. There was 14 volts there. Look at that. 14.9 volts. And now it's draining away. Fantastic. Pretty sure we didn't have that before. It's been a while since I did the other part of the video. I think I'm going to put this back together and see if it's working. Bear with me, I'm going to put this back together. I don't need to film that. I might put some fresh thermal paste on there and then we'll see if it's doing what it needs to do. There might be numerous other things wrong with it, or it might be just that. Maybe the water damage hit it, took out that chip there because the feedback part of that, and it could be as simple as that. Fingers crossed. I am going to use some second wonder stuff. Obviously isopropyl alcohol is the only and true one love of my life, but this comes a close second. And just in here, we think it's working, but it does look a little bit rusty, so I'll put some IPA in it. And now I'm just going to spray some of this in it, and hopefully it might work its way in. And clean up the contacts if they are a little dirty. Something like this I wouldn't be able to sell on because it's been water damaged. Don't know how long it's going to last. But sort of thing, I don't think I'd use it myself, but friends and family, as long as they know the backstory of it, then I'll be happy to give it to someone I knew. Right, we're back together. I've got that in the right place. Goes round to max. It all went all right. Just took me a little bit of time to work out where the fan goes, but there is an actual plastic moulded bit for the fan to sit in, and it comes up here around this sort of area. That's where the fan is. Now look in here, it says that on a full tank you get approximately 16 hours, and here it says aromatic box, so it looks like you might be able to put some kind of scents in there to aromas to fill the room with that. Outlet, water level control valve, float, so this is the float here. I can see that there's a thing that move up and down here, and that's the atomizer here. Also says filter. Right, so I'm gonna have a little read up and then we'll plug it in. We'll see if it does anything. Okay, I haven't turned this on. I haven't even plugged it in to see if any light lights up, but you can see I've got some water in here. The instructions are not that clear. I don't know how much water you can put in. I suppose it doesn't really matter because there's this bit here which is pushing the humidifier air up, the mist up. Right, I'm going to place this on here. There's a little valve here. I did press that valve and water shot out in the sink. So that's how the float thing operates here. So I suppose it will only take as much water as it needs, and then this will lift up and will stop more water from going through. So now water will, when I do this, flood out. I can hear it. Now, it might instantly go bang. It's off here at the moment. Here we go. Hands are relatively dry, slightly nervous. Right, turn on. Now, is it going to go instantly bang? Move away. Okay, we've got a green light. Oh my word, it's out already. How can it be that quick? What sort of sorcery is that? How quick is that? Oh my word. I don't know if you can see that or not. I'm not sure if you can see it coming out. That is flying out of it. Yeah, you can see that. Whoa. And it's cold. And that's on a low setting. Now, I wonder with my little chip here, will it make a difference on low or high? Maybe because it's the wrong chip, it's on high straight away, because that seems extremely high. So, that's off, that's on, that's the lowest setting. That is crazy, honestly. Right, here we go. Let's put it up full, see if it goes bang. Doing it bit by bit. Right, I'm all the way up now. Yeah, there's more. Do you know, that's like a... it's like a smoke machine. There's that much mist coming out of it. I am in shock. I have to find out. There's a big one and a small one. What's the point? You know, how do you block up that big one? Is there a way that you can put it round where it blocks the big, so you can only have the small out? As far as I can see, that is there's 2 holes there. That doesn't seem to make any difference. Look at that. Right, well, I mean, initially it appears to be working. Is that chip correct? I have no idea. It's amazing. Look how small that is there. That's the chip that came out of it. So yeah, I don't know. I mean, it's working now. I think water damage must have affected that chip, and I think it affected the feedback section of that chip. I'm going to lower it down because it is actually, feels like I'm in a rainforest. Massive thanks to Anonymous Repair. I know he hasn't helped on this video, but his knowledge on the Xbox Fridges video has helped fix this one here. I'm really pleased with that one. I've never seen a humidifier before, and I don't think I've seen somebody attempt to fix one before. It's an interesting device. Anyway, I hoped you enjoyed this one here. I thoroughly did, and I think it's a very interesting device. Thanks for watching, everyone.